Alright guys, welcome back to another video. So today we will be looking at an example where we have a term in our particular solution form that also exists in the homogeneous solution. And that creates a problem because we'll have that linear dependence that I've been alluding to for the past few videos. And as a result, our method of undetermined coefficients will fail because the particular solution cannot contain any terms of the homogeneous solution. So instead what we're going to have to do is modify the particular solution just a bit, and we will see how all that comes out to play. So, first step, homogeneous solution. The homogeneous solution satisfies this differential equation. And we can solve this pretty easy. We get r squared plus r minus 2 is equal to 0. This factors to r plus 2 times r minus 1. So r is equal to 1 and negative 2. So this gives us a homogeneous solution of c1 e to the t plus c2 e to the negative 2 times t. And so if we move on to the next step and try to determine the particular solution, we have 3e to the negative 2t, and as we continually take derivatives of this, this will always be an e to the negative 2t with some coefficient on it. So naturally we would say, okay, let's let our particular solution be a e to the negative 2t. Now keep in mind that this particular solution is included in the homogeneous solution right here. So we have this linear dependence going on. But let's go ahead and just work through it real quick and let me show you how this comes out. So if we were to actually move on and continue using this form, even though we have that linear dependence, then this is what would happen. So we would get a yp prime, which is equal to negative 2a e to the negative 2t. We would get a yp double prime of 4a e to the negative 2t. And if we plug these back into the differential equation up here, then what we would have is 4a e to the negative 2t minus 2a e to the negative 2t, and then minus 2a e to the negative 2t again. And this has to equal the right-hand side, which is 3e to the negative 2t. But what we see is that all of these terms cancel out. So we have 0 is equal to 3e to the negative 2t, but this can never happen. So we've reached some sort of contradiction and our method of undetermined coefficients fails. And the reason it fails is again because we have a term in our particular solution that is part of the homogeneous solution. This guy is really this guy, and we can't have that. So the way around this is to modify our particular solution by multiplying through by t. So we're not going to use this guy, and instead we are going to use yp is equal to a times t e to the negative 2t. So we've modified our particular solution by multiplying through by a t. And now what we do is we look at our new particular solution and we check both of these guys to see if it's still included. If we still have a term in our homogeneous solution that matches this form even after we multiply by t, then we're going to have to multiply by another t and we get an at squared. But that is not the case in this example, so we are fine with using this particular equation right here. So let's move on to step 3 prime. So we can go ahead and differentiate our modified particular equation. So yp prime would come out to be a e to the negative 2t minus 2at e to the negative 2t. And then our yp double prime would come out to be negative 2a e to the negative 2t minus 2a e to the negative 2t plus 4at e to the negative 2t. So now we can plug this back into our differential equation. So we have y double prime, which is negative 4a e to the negative 2 times t plus 4at e to the negative 2t, and then plus a y prime, so plus a e to the negative 2t minus 2at e to the negative 2t, and then we have minus a 2y, so minus 2at e to the negative 2t. And this all has to equal the right-hand side, which is 3e to the negative 2 times t. So first let's go ahead and get the e to the negative 2t's all together. So we have a minus 4a and then plus a e to the negative 2 times t. And now let's go ahead and get the t e to the negative 2t's together. So we have a 4a minus a 2a and then minus another 2a, and t e to the negative 2 times t. So all this has to equal 3e to the negative 2t. So we see that this cancels out to 0. 4a minus 4a is 0, and that is okay because we had a 0 coefficient in front of the t to the negative 2t on this side. So we're fine there, and we still have another solution where we can solve for a. So we are still able to determine our undetermined coefficient. So our equation is negative 4a plus a has to equal 3, the coefficient on this guy. And that gives us a is equal to negative 1. And with that, we can assemble our general solution. So y is equal to the homogeneous plus the particular. So y is equal to c1 e to the t plus c2 e to the negative 2 times t, and then plus a, which is negative 1, so it would actually be a minus, and then t e to the negative 2 times t. So here is our solution, and we still did it using the method of undetermined coefficients, but we had to add a slight modification by multiplying through our original particular solution by a t. And again, the only reason why we did that is because our original particular solution form was linearly dependent with a term in the homogeneous solution, which made it impossible for us to solve. It gave us this contradiction, so we modified it by multiplying by a t, and we were able to successfully use the method of undetermined coefficients. So anyway, thanks for watching, and next time we will finally be moving on to a different method called variation of parameters. And this is a method that is more generalized, and we will be able to solve a lot more classes of non-homogeneous differential equations using this method. So see you then.